Access, May 11, 2024. Sound personalization for the hard of hearing in noise and zero gravity. Larry Guterman.
This presentation is about, it's called Auralia, which is sound personalization for the hard of hearing in noise and zero gravity. And the team is me. I'm the project lead and the co-founder of SonicCloud. And Brenda Williamson is my partner there, recent aerospace engineering graduate, and the team from SonicCloud are the engineers. So what is a zero gravity flight? It's a parabolic flight. It takes about an hour, hour and a half. The plane makes 45-degree climbs and then dives. And during the dives, everyone is in free fall. So there's zero gravity and you're able to float as though you're floating in space. So what the experiment does is it uses a custom-built sound personalization software together with noise-canceling headphones in order to enable someone who is severely hard of hearing, in which case that's me, to be able to understand speech in the noise and the disorienting environment of a zero gravity flight by using innovative controls for identifying listening preferences, making real-time adjustments, using sample profiles, which cover a wide range of hearing loss, and using digital signal processing to modify the speech signal and tailor it very specifically to the hearing acuity or hearing loss of the listener. So just a quick background. Audiogram is a measure of the hearing acuity of a person. Horizontal axis represents the pitch or the frequency. The vertical axis, and it's inverted in audiology, represents the loudness. So louder is on the bottom. Normal hearing goes from 0 to about 25 decibels, quote unquote normal hearing. Mild hearing loss goes from about 25 decibels to 40. Moderate hearing loss goes from 40 decibels to 70. And severe hearing loss goes from 70 to 90. And profound hearing loss goes from 90 to 100 and above 90 decibels. So that's on the left-hand side. That is a quote unquote normal audiogram at the top. On the right-hand side is my audiogram. And as you can see, there's severe to profound hearing loss, especially in the speech frequencies. If you look at 2000 hertz, you can see way down at the bottom, that is the sound of an SH. And above that, you get the S and the TH and the F. Those are the sibilant sounds. And those are the sounds in speech that give you speech understanding. So when you have hearing loss, often you can get awareness of sound. If you're not completely deaf, you get awareness of sound, but everything sounds very muffled because you're not getting any of the discrimination of those consonants and sibilants. So the purpose of the experiment we're going to be running is to try to improve speech understanding, live speech understanding for a flyer on a zero gravity flight in a disorienting environment with loud background noise so that we can prepare folks in the future who may go on the space station, which is extremely loud, by the way, because of all the machines running, or may go on a ship and may need to be able to communicate and hear and understand in that environment as well. And so among the components of the prototype experimental SonicCloud sound personalization software, which is going to be running on an iPhone, include a hearing test, self-fitting adjustments, live ambient sound capture, signal processing that optimizes for speech on one hand and music on the other, sample profiles, sample hearing profiles, an innovative user interface that allows for real-time adjustments and changes. So just to give you a little bit of a picture of what that looks like, we have pre-flight elements, which include a hearing test. The hearing test is fun and engaging. It uses different characters to represent different frequencies, the low pitches on the left and the high pitches on the right, one for each ear. And then an audiogram you can see on the bottom of the screen here is generated, which tells you which letters you're in phonemes you might hear well, and which letters and phonemes, which are parts of speech that you might have difficulty understanding. That data is then captured and populated into what's called the signal processing filter bank in the software. And then there's a further step with SonicCloud, pardon me, software, in which you can make your own adjustments. So the software will ask you, how did that sound? Is it better but still a bit muffled? Is it too tinny? Is it too sharp? and then it'll provide sound like serious baseball fans. You can see there in the top middle where you're able to you listen to that over and over again, and you make an adjustment to the letter S with your fingers, and it adjusts the audio associated with the letter S. It makes it just sharp enough, not too shrill, not too muffled, and you control that because only you know what's going on inside your brain. And there are a couple of other visual metaphors, like on the top right, there's you can make the sound less tunnely or more tunnely sounded. In the bottom middle, you can make the sound more natural or less natural sounding. Once you're done with getting it to where you want it to be, you can toggle back and forth between unprocessed and processed sound, sort of like you can do it, is this better, is that better scenario, like you might at the optometrist, but with your hearing. And then you can save out your profile that you prefer. This is all part of the setup. Once you've got the profile that you prefer, it will show up in a drop-down menu on your phone. So what the experiment will consist of, it will include the software running on the mobile phone and AirPods, and the AirPods will be enabled for noise cancellation. And the hardware that will be used will be, again, the phone itself, a wrist strap, which will allow my partner, Brenda, to be able to strap the phone to her wrist, and then control it, obviously, via the user interface with her fingers. AirPods that I will be wearing, and ear hooks that go around the AirPods to make sure they don't go flying out of my ears during the zero gravity flight and floating around the cabin. And the app will be set up in ambient mode, as you can see here, and we'll select basic tuning. Somehow this got moved. Okay, so during the flight, at the beginning of the flight, we'll be doing what's called some word testing, which is a classic audiology test to determine how well I can understand words. So that'll be before we go into zero gravity, just as a test. On the left here, in the upper left corner, you can see what the user interface looks like. So my profile, if you look down in the bottom left corner, you can see 7 sample profiles that appear. So I can select one of those sample profiles, or I can select the profile I already created using the hearing test. If I select one of the sample profiles, I can then continue to make further adjustments to listen to how things sound. I can adjust on the right-hand side, and this is hard to see, but a richness, vowels, consonants, and sharpness control. And on the left-hand side, comfort, which is input gain, boost, which is output gain, and fullness, which is compression threshold. I can do that for the left ear and the right ear. Dial in my profile, the one that I like, and then listen to the words being presented by my partner. And there are several word lists so that you're not repeating the same words and you're not using your memory to be able to determine whether you understand them. And we'll do a test. We'll test with SonicCloud on using my hearing profile, and with SonicCloud off, just using the Apple AirPods, and see how I do. And presumably I should be able to do better using my personalized sound. And during the ascent, the basic experiment, again, will consist of us floating in zero gravity while my partner, Brenda, delivers commands or instructions to me, and I will respond to her with hand signals saying, okay, yes, I understand, or no, I don't, or I'm having technical problems. And she will kind of absorb and internalize the average amount of understanding that I'm getting, make sure that I am understanding her, and kind of put that together in a bit of a case study afterwards to convey how I did in the process and whether I understood her. Also note that because we'll be floating, we may be upside down at some point. So I won't really be able to lip read and gain information that way, because it'll be very disorienting. So here are some photographs from December 22's zero gravity flight using SonicCloud. We had a much less slick setup. We had a tablet with SonicCloud running on the thigh of the listener, and the support staff was delivering the message via large headphones that were Bluetooth connected to that tablet. The tablet included this software-based sound personalization that was then delivered to headphones that the flyer was wearing right there, Sony headphones. So now we've made it a lot more streamlined. We're simply using Apple AirPods, which I've got right here, and an iPhone, which contains the program instead of a large tablet. The iPhone acts as a microphone. the sound goes from the iPhone to my AirPods, but because the iPhone contains the sound personalization, the sound is processed for my hearing loss. Here are some other, is Anna with Dr. Renee Horton. Here are 3 of the 4 ambassadors who used SonicCloud on the last flight. Here's another person on the flight who has a different disability. And here's the group that was either support staff and or went on the flight that day. And here is an image of me testing out SonicCloud in advance. On the right-hand side is my partner who's speaking into the phone. It's very hard to see, but I'm wearing AirPods here. And the computer there is putting out about 85 decibels of background noise. The airplane cabin will have about 90 decibels of background noise. And I'm about 12 feet away from this person. And I'm able to not only hear what they're saying, but understand what they're saying based on the sound being personalized for my hearing loss. There's some background research links, which I'm happy to provide at some point if people are interested on the rate of hearing loss in the country and the problems that people contend with hearing loss, largely in the workplace, but also at home. And there's just been a release by the National Acoustics Laboratory, which is the national, sort of the global body for setting hearing aid standards and hearing assistive technology research, which has just done some research actually using SonicCloud relative to Bluetooth streaming for hearing aids and finding that it's useful to recommend folks use both software enhancement and hearing aids and try both. Some will work better than others, and it depends on the individual. And that actually just came out. The study actually has not been peer reviewed yet, but they just released some preliminary results from that as well. And that's my presentation. So, not much time for questions, sorry.
It's all right. Thank you so
Okay.
much, Larry. We do have about 2 minutes now for questions, if there are any. If anyone would like to submit a question for Larry to answer, you can use the Q&A function, which will be on the bar either at the bottom or at the top of your screen. I asked this question of Brenda earlier, so I will ask it of you, Larry, now. What are you most excited about with your upcoming flight?
Oh, well, maybe there's a fine line between excited and anxious. But I'm actually very excited to what we're going to try to do actually also on the flight is set things up so that I can actually use the application to listen to my favorite song, which is Here Comes the Sun, while I'm in free fall. So I'm hoping that will be a very transcendent experience.
That's excellent. I love that little fun fact for your research. We do have another question in here from you, or for you, from Gala, asking for autistic people who may use noise canceling devices, how would this technology work?
People who use noise canceling devices, is that the question?
Yes, so someone who might typically use noise canceling devices, how would this work with them?
So in this case, the processing is happening in our prototype. The processing is happening on the phone itself. So the phone acts as a microphone and it sends the sound to your headset. So it's independent or sort of orthogonal to the noise cancellation, which is layered, I guess, on top or independently of. And so, for example, in the case of the Apple AirPods, there's noise cancellation that cancels out the noise coming in around you. And then the sound is being piped from the microphone on the cell phone going directly into the headphones. Now, there's a third aspect, which is noise reduction. I'm getting confused between noise cancellation and noise reduction, where you might want to cancel the noise coming into the microphone that the speaker is speaking into. And that's a third component. We're not doing that currently, but the phone actually does a pretty good job of automatic noise reduction from that end. But the AirPods do an amazing job of noise cancellation of the sound coming around, going directly into your ears, the ambient sound. So you can use any device with noise cancellation and use the technology.
Psi Access. Learn more at www.psiaccess.org.